Thank you very much for giving me the opportunity of talking to this audience. And about this topic that is, I promise, is really simple. What is interesting here is the utilization of this verb, circumventing the diffraction limit and not surpassing. My talk will be mainly focused on fluorescence optical microscopy, and you will understand immediately why. But as I don't know, many of you arrived yesterday, but if you arrived yesterday, I think that you were in the middle of a crowd that was celebrating, unfortunately, a great football player that was Eusebio. And so I was in this kind of celebration. I'm not happy because it was the funeral, but happy to be within this kind of celebration here. I come from the Italian Institute of Technology, that is a newborn institution in Italy for research and for transferring research to companies, to industry, for having the country more competitive and Europe more competitive with respect to other companies or countries. And what is nice in this building that is not nice in terms of architecture is that within this building we have a lot of abilities, let's say, from robotics to neuroscience to smart materials to energy devices. And I think that we benefit of this kind of variety of research platforms that we have and that we can share there. And we, as the Nanophotonics group as well. So I have a department that is the Department of Nanophysics. We are more or less 110 people working on different aspects of nanophysics. And then there is my group that is a group devoted to optical nanoscopy, so improvement in optical microscopy. I don't know if you know some of these guys, they are very young. The average age in IIT is 34 years. But maybe some of you in the optics field know Colin Shepard that joined our group and is the inventor of the confocal microscope and many other devices in microscopy. Motivation for our work, and I hope that you can be interested, maybe not in the motivation, but in some of the solutions we had, is try to visualize, track, and quantify events in biological systems, but in a special way today, that is try to work on cell aggregates, small organisms, organs and tissues. So trying to bring all the advances we can have in microscopy within the human body, starting from experiments on organs and tissues and cell aggregates in order to understand which can be the